Welcome to PreMath. In this video, we have got this yellow shaded triangle ABC along with this angle bisector CD, as you can see in this given diagram. In other words, this angle BCD is alpha, and likewise this angle ACD is alpha as well. And moreover, this side length BC is 6 units, whereas the other side AC is 9 units. And furthermore, this segment BD is 2x minus 1, and the segment AD is x plus 2. And now our task is to calculate the area of this yellow shaded triangle ABC. Please don't forget to give a thumbs up and subscribe. And please keep in mind that this figure may not be 100% true to the scale. Let's go ahead and get started. Before we could calculate the area of this yellow shaded triangle, we must find the value of x first. And now let's recall the angle bisector theorem. According to this theorem, in this given triangle ABC along with this angle bisector CD, then we can see the ratio of these two side lengths A and B is going to be equal to the ratio of these two segments C and D, as you can see in this given proportion. And we are going to apply this concept on this given problem. This CD being the angle bisector, we can write the ratio of BD and AD. Let me write down the ratio of BD and AD is going to be equal to the ratio of these two side lengths BC and AC. Let me write down BC divided by AC. And now we can see this BD segment is 2x minus 1. So I'm going to replace that one with 2x minus 1. Likewise, AD segment is x plus 2. So I'm going to replace that one with x plus 2. And for this BC, this side length is 6. And finally, this side length AC is 9. As you can see in this next step. And now let's look at this fraction on the right hand side. 6 divided by 9 reduces to 2/3. So therefore I can write 2x minus 1 divided by x plus 2 is going to be equal to 2 divided by 3. And now I am going to cross multiply. So when we cross multiply, we're going to get 6x minus 3 equals to 2x plus 4. And in this next step, I'm going to move this 2x on the left hand side, and at the very same time I'm going to move this negative 3 on the opposite direction. So therefore we can write 6x minus 2x equal to 4 plus 3. So therefore we got 4x equal to 7. Let's divide both sides by 4 to isolate x. 4 and 4 is gone. So therefore we figured out our x value as 7 divided by 4. So thus our x value turns out to be 7 divided by 4. And we are going to substitute this x value over here. I'm going to substitute that one, 7 divided by 4. If we simplify everything, this our BD length turns out to be 5 divided by 2. And I am going to substitute x value as 7 divided by 4 over here as well. So therefore this AD side length turns out to be 15 divided by 4. And now this whole side AB is going to be the sum of these two segments, 5 divided by 2 plus 15 divided by 4. If we add these two fractions, that is going to give us 25 divided by 4. So thus we can see in this triangle ABC, this side length BC is 6 units, this side length AC is 9, and this side AB turns out to be 25 divided by 4. So therefore we are going to use the Heron's formula to calculate the area of this yellow shaded triangle ABC. And here's our formula. The area of the triangle is equal to the square root of s times s minus a times s minus b times s minus c, where s is equal to side lengths a plus b plus c all over 2, where this lowercase s is called the semi-perimeter. And now I'm going to label this side lowercase a, this side lowercase b, and this side lowercase c. Then our lowercase a value is going to be 6, lowercase b value is 9, and lowercase c value is going to be 25 divided by 4. And now we are going to calculate this s value by just simply substituting these a value as 6 plus b value as 9 plus c value as 25 divided by 4 all over 2. And if we add all these numerators, this adds up to 85 divided by 4. So therefore I can write down s is going to be equal to 1 divided by 2 times 85 divided by 4. And if we multiply and simplify, our s value simply turns out to be 85 divided by 8. So thus our s value turns out to be 85 divided by 8. And now we are going to substitute all these values. I'm going to replace s with 85 divided by 8, this a with 6, b with 9, and finally this c with 25 divided by 4. As you can see in this next step, I have substituted all those s values over here, and likewise our a, b, and c values over here as well. And now I am going to tweak this 6. I can write this 6 as 48 divided by 8. Likewise this 9 could be written as 72 divided by 8, and likewise this 25 divided by 4 could be written as 50 divided by 8, as you can see in this next step. And this way we got the common denominators as 8. And now let's focus on this fractions, this first parentheses. If we subtract these one, that is going to give us 37 divided by 8. And in this second parentheses, if we subtract these fractions, that is going to give us 13 divided by 8. And finally for this third parentheses, if we subtract that one, that is going to give us 35 divided by 8, as you can see in this next step. And now let's make an observation. At the numerator, 85 could be written as 17 times 5, and likewise the numerator 35 could be written as 5 times 7. And here we can see 5 times 5 is going to give us 25. So therefore if we simplify, on the right hand side the area of this yellow shaded triangle is going to be 5 divided by 64 times the square root of 57,239. So thus the area of this yellow shaded triangle turns out to be 5 times the square root of 57,239 divided by 64 square units. And that is going to be approximately equal to 18.7 square units as well. And that's our final answer. Thanks for watching, and please don't forget to subscribe to my channel for more exciting videos. Bye.